All right, guys, what's going on? We are going to learn something super awesome today. Hope you guys are ready for this. All right, yesterday or the other day, we were doing long division. Can I remind you guys about long division? You don't have to write this part down. Let's just look for a minute. Okay, if I try to do long division and I divide this, here are our steps for long division, okay? We'd say x goes into x to the third how many times? X squared. I multiply it down and I get x to the third, and I multiply it down and I get 3x squared. You guys remember that the next step was always change your signs. Okay, so that crosses out and I get 7x squared, and I bring down the 5x. And then I do the whole process over again. X goes into 7x squared 7x times. I multiply it. I get 7x squared. I multiply it. Minus 21x. Change signs. Negative 5 plus 21 is 16x plus 5. All right, last round. X goes into 16x how many times? 16 times, okay? Multiply that, change signs, and I have a remainder of 53. We talked about the way that you write the remainder is 53 over the thing you were dividing by. Okay? Long division. Now, you absolutely love doing long division. You could do it all day long. Raise your hand. Yeah, no, guys. Long division is a pain, okay? So today I'm going to teach you something cool. It's called synthetic division. It's a little trick that helps us do this exact same thing a bit faster, all right? Okay, so what I want you to do is you always draw this little thing. And what we do is we take the zero of this, or the solution of that. Okay, what does that mean? Well, it means if I were to take x minus 3 equal to 0 and add the 3 over, x is 3, that's the number I use right here, all right? So a lot of my students will remember it by thinking like, oh, it's the opposite sign. And that's fine, it is the opposite sign, but it comes because it's the 0, okay? And then what I'm going to do is I'm going to take what's called my coefficients, right? You guys know what coefficients are. They're the numbers in front. I'm going to use 1, 4, negative 5, and 5. I'm going to drop a line down right there. Okay, so this is how we set it up. And then this is how you do synthetic division, all right? We start by bringing down the first term. So I just bring the 1 straight down. And then what I want you to remember is multiply, add, multiply, add, multiply, add. Okay, step 1, go up here. Multiply that. All right, so it's like that times that. 1 times 3 is 3, add. That's 7. Okay. Next, multiply that. 7 times 3 is 21. Add. That's 16. Multiply that. 16 times 3 is 48. Add. That's 53. Those numbers look kind of familiar. Let's look over here. Look. 1, 7, 16, 53. It does it so much faster, and you guys can get like really quick at this to where you're able to do synthetic division very quickly, all right? Now, when you're done, you go like this. You go, okay, I started with x to the third. I divided out an x, so this is an x squared. So it's 1x squared plus 7x plus 16. And then this last number is my remainder. And I could put my remainder over x minus 3. And that's my answer. And see how much quicker that is than doing it with long division, okay? So from now on, unless you're specifically told, all right, do this by long division, we're going to actually use synthetic division, and it's going to be faster. It's going to be awesome, all right? Okay, so let's go ahead and look at number 2 here. Okay, so remember that we take the 0 of this. Well, x plus 2, if I were to solve that, x is negative 2. Okay? and then I come over here and take the coefficients. Now I do need to tell you one thing. This polynomial right here, that's actually not this polynomial's full name, okay? This polynomial's full name is x to the third plus 0x squared minus 7x minus 6. When we call polynomials by their full names, if I start with x3, then I got to go x2, and I got to go x1, and then I got to go x to the 0. But you have to use every number in between. So if it's missing a number, you need to make sure to include 0x squared. All right? Okay, so we'll make sure that we get that idea. Down, just make sure it goes like 3, 2, 1, 0. So that when I write my coefficients, it's going to be 1, 0, negative 7, negative 6. All right, and here we go. Bring down the 1. And then you guys remember our steps. We multiply. So that's negative 2. And then add. 0 plus negative 2 is negative 2. Multiply. Negative 2 times negative 2 is positive 4. And then add. That gives me negative 3. Multiply. Negative 3 times negative 2 is positive 6. And add. That gives me 0. Now that's actually kind of cool. When I get a remainder of 0, what that means is that this divides evenly. Okay, so that's the easy way to say it, is it divides evenly. Another thing, it tells me a couple of things that we're going to list out over here. It tells me that this number right here, okay, negative 2 is a solution to that polynomial. All right? Tells me negative 2 is a solution. You know what else it tells me? It tells me that x plus 2 is a factor. We're going to use these words a lot, okay? I want you guys to get used to the words solution and factor. If it's a factor, it means it divides evenly. And if it's a solution, it means when I plug it in, I get negative 2. So it tells me that. Now, what I do then is I take what was left right here, and I make an equation out of it. If I started with an x to the third and I divided by an x, I'm down to x squared. So 1x squared minus 2x minus 3. So if I divide those, it divides evenly with no remainder, and it equals x squared minus 2x minus 3. Okay? Now, something that's really, really interesting about synthetic division, there's something called the remainder theorem, which always kind of blows my mind. This is so cool that it works. So I want to show you guys something really quick, all right? Let's say I had to evaluate f of x at 2, which is what this is saying. It's basically saying plug in 2, okay? So I'm going to take this function, but I'm going to plug in 2. So I'm going to get 2 to the third minus 4 times 2 squared plus 5 times 2 plus 3, okay? When I do that, I get 8. All right, 4 times 4 is 16 plus 10 plus 3. So 8 plus 10, that's 18, 19, 20, 21, minus 16 is 5. When I plugged in negative 2 for x, I got 5, okay, which tells me f of, or just regular 2, f of 2 is 5. Okay, that's what I figured out right here. Well, what I'm going to do right now is I'm actually going to do synthetic division, okay? Let's just see what happens. Now, what I do is I take this number and I put it right here. This time you do not have to do the opposite because 2 is already the number we're using. It's not like it said x plus 2 or x minus 2. It's just 2. We're going to use that number. We're going to come up here and we're going to get all the coefficients. So my coefficients are 1, negative 4, 5, and 3. All right. Okay, you guys remember our process? Let's see if we can go through this real quick. Multiply. 1 times 2 is 2. Add. That's negative 2. Multiply. Negative 2 times 2 is negative 4. Add. That's 1. Multiply. 1 times 2 is 2. Add. That's 5. Okay? You see where I'm going with this? The remainder, when I do synthetic division, is the same as the value of the function. So if you had a really big equation and you had to plug a number in and you didn't have your calculator, let's say like 2 is not that hard to plug in, but let's say it was like 10 or something, or 50 or something like that, you can do synthetic division instead of plugging it in, and the answer you get will be the answer you would have gotten if you had plugged in 2. Okay? So that's the what the remainder theorem says. All right? Let's take a look at another one of the remainder theorem. Okay, so I'm trying to find the value at 3. See, you guys, if I tried to plug this in, and let's say I didn't have a calculator, that would really kind of stress my brain out, right? Because it'd be like, okay, 3 to the 4th is 81. 3 to the 3rd is 27, but then what's 27 times 5? That's a little difficult. That's, I mean, I guess it's like 135. 3 squared is 9 times 5 is 45, plus 15 minus 6. And then I have to add all that up. Okay? Look how fast I can do it once I start getting good at synthetic division. Okay? So I got my numbers. 1, negative 5, 5, 5, 6. Okay, check this out. 1 times 3 is 3. That's negative 2. Negative 2 times 3 is negative 6, that's negative 1. Negative 1 times 3 is negative 3, that's 2. 2 times 3 is 6, that's 0. So I guess if we added that all together, you guys could do it on a calculator or something, since the numbers are kind of big. If I added that all together, I should get 0. Let me see. 81 minus 135 plus 45 plus 15 minus 6 is 0. All right? So my answer is 0, my remainder is 0. Again, anytime you got a remainder of 0, I want you guys to remember a couple things, all right? That means that this number right here, 3, is a solution. You guys remember we've talked about this. What are other words for solution? So other words for solution are x-intercepts, zeros, and roots. Okay, x-intercept, zeros, roots. 3 is a solution, which means 3 is also an x-intercept. All right. The other thing that we know, even though it didn't ask me this, I'm just going to write it so you guys can see it. The other thing that we know is x minus 3, where that came from, is a factor because it divides evenly. All right, so these are all things that we'd learn when we get a remainder of 0 on synthetic division. Okay? Okay, last part. Now this is what we're going to kind of get into for the end of this chapter. We're going to do a question here, and then we'll be talking about this more in our last section. All right? We want to find all the solutions of this. Remember when we're looking for solutions, you guys, we're looking for points where it touches the x-axis. We're looking for x-intercepts. Okay? But when I look at this, like, this doesn't factor. I can't do grouping. I can't do anything to solve this. All right? Well, the only way that I can really do this is because it specifically told me negative 2 is a 0. What that means is that if I do synthetic division with negative 2, what should I get at the end right there? Well, if it's a 0, that means it's a solution, which means my remainder should be 0. Okay? So it told me that, so let's see if this actually works, right? Let's go ahead and look at my numbers here. 2, negative 3, negative 11, 6. 6 will go on that side. I'm going to go do my synthetic division real quick. It goes like this. Bring that down. Multiply. That's negative 4. Bring that down. That's negative 7. Multiply. Positive 14. Okay, negative 11 plus 14 is 3. Bring that down. Multiply. Negative 6. Solution. My remainder is 0. All right? That's great. So that tells me that, yes, negative 2 is a 0, or solution, or whatever you want to call it, because I got to 0 at the end. But now it wants me to find all the solutions. So how do I find the rest of them? Okay, well, this is the important part here, guys. What I'm going to do is take this, and I'm going to turn that into an equation. Remember, it started with x to the third, so I'm going to turn this into an x squared equation. I'm going to set it equal to 0, and I'm going to use that to find my last two solutions. All right, now you guys recognize that? This is a quadratic. Whenever we go down and do synthetic division, we always end with a quadratic right here. So let's figure out what this quadratic is going to be for the solutions, okay? You guys, you have two methods to solve a quadratic, all right? I will go ahead and show you both. One method is by factoring. One method is by using quadratic formula. Now, I do want you to notice that this has a number in the front. So some of you guys don't love factoring when there's a number in front, and that's okay. So you can just use quadratic formula if you want, but I'll go ahead and show you both ways, all right? Here's how I do factoring when there's a number in front. I go like this. All right, 2 times 3 is 6, and on the bottom I'm going to put -7, and I'm going to say what multiplies to make 6 and adds to make 7, 6 and 1, to get -7, it's minus, minus. But I have to remember that because I had a leading coefficient that I multiplied in, I need to divide it out. So sometimes we call these like star problems or something like that. All right, because it kind of makes a little, instead of an X, it makes like a star in there. Well, look, guys, 6 over 2, that's 3. 1 over 2, that's 1/2. We're really super duper close to the answer, but there's one thing we have to do, okay? I sometimes call this bottoms up. Anything left on the bottom comes up right there. All right? So instead of it being x minus 1/2, it's 2x minus 1. So this is what this equation would factor to. All right? It factors to x minus 3, 2x minus 1. When I go to solve each of those, okay, I would add the 3 over here, so x equals 3. I would add the 1 over, so 2x equals 1, and divide by 2. So x equals 1/2. Okay? So that's how I would do this by factoring, if I wanted to do factoring, all right? Now, if you guys are not good at factoring, that's fine. Guess what? The quadratic formula will work every single time. A is 2. B is -7, C is 3. So let's go ahead and do a quadratic formula here, okay? Negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, that's my quadratic formula, okay? So first I'm going to look at this. I'm going to say, okay, that's +7. Now inside my square root sign, -7 squared is 49. 4 times 2 times 3 is 24. And 49 minus 24 is 25. Now, because this is a perfect square, I'm going to go ahead and take the square root of 25. Okay? So this is going to be 7 plus or minus 5 over 4. And I'm going to go like this. I'm going to do plus first. Okay, 7 plus 5 over 4. That's going to be, move it down here, that's going to be 12 over 4, which is 3. Then I'm going to do minus, okay? 7 minus 5 over 4, that's going to be 2 over 4, which is 1/2. So what were my solutions? 3 and 1/2. What were my solutions? 3 and 1/2. All right, so you guys kind of see that whether we do factoring or quadratic, I'm going to get the same answers. Now, don't forget that I had a solution up here, -2, 3, and 1/2. All right, so let me write this down here. All my solutions are -2, 3, and 1/2. Okay? Okay, here's something cool I'm going to show you real quick. We can kind of check our answer. I'm going to take this original problem right here. I'm going to go graph that on Desmos, okay? 2x to the third minus 3x squared minus 11x plus 6. All right, so I'm going to go to Desmos right here. I'm going to go 2x to the third minus 3x squared minus 11x plus 6. Okay, so check this out. A little bit of a better graph. There you go. All right, you guys. Where does it cross right there? -2. Where does it cross right there? 0.5. That's 1/2 and 3. So I can see that my solutions are -2, 1/2, and 3. And what I get over here? -2, 1/2, and 3. All right? So we'll be working on that concept too a little bit more tomorrow. Hopefully you guys understood the synthetic division. All right, great job.